Let us wait for another 5 minutes. Chalo, before the class gets started, what's up, people? How's it going? Do you have any questions that we need to discuss before the class starts? And yeah, let's talk about the questions that you have before we start the class, and then we'll discuss something else. Am I audible?
Yeah, you are. Hey,
Yes.
hey.
Yeah.
Yes, you are audible, Darshan.
Uh, Varma,
Mm-hmm.
regarding the tokenization,
Mm-hmm.
you said that the tokens are being divided may not be the words,
Mm-hmm.
right? And you have
Mm-hmm.
given an example. In that
Mm-hmm.
example, the word
Mm-hmm.
doesn't have any meaning at all.
Mm-hmm.
Some artificial intelligence, RT,
Mm-hmm.
and facial likewise.
Mm-hmm.
So in that case, how the
Mm-hmm.
embeddings are being assigned?
Yeah. Nice question. So, we are not just directly giving in the tokens into the model, actually. As a part of NLP, we have few other steps that are lined up after tokenization. So once the tokens are generated, we do two processes called as stemming and lemmatization. These are two processes to remove all these unnecessary words and bring those words to the root form, which holds some significance, which holds some meaning.
Okay, yeah,
So after that,
okay,
we turn them into embeddings.
okay. That pre-processing task will be done as
Yes,
a part of tokenization itself.
yes.
Yeah,
We're not
thanks,
going
Varma.
to do it manually.
Yeah,
It is done by the developers. We're just
yeah,
going to
yeah, yeah,
receive
yeah.
the
That's
text. Yeah.
yeah. Thank you.
Yes. And think what's the count now? It's 19, and I think more people should join. Okay, let me ask how many of you have already enrolled to the course? You can raise your hands. I'll just count the number.
Myself as well. Uh,
Okay. So I just see 8 people enrolled successfully. And what about others? How many of you are joining this class for the first time? You can the previous question, whoever have raised their hands, they can drop down. Okay. I see out of 20 people, we have two people who's theirs it is a first class. Okay. Deepak and Kunal, did you watch the video recordings of previous classes?
Yes, Akshan. I went through the recordings yesterday. Yeah.
Okay. And Kunal, what about you?
I'm not currently. I'm not gone through any video lectures.
Okay, you can go through them to have better understanding of why we have this meeting and what we are discussing about. Maybe after this class, you can have all the videos lined up and watch them. Okay, right. How many
Okay,
of you are
okay.
planning to enroll yet, but not enroll yet? Okay. So whoever is planning to enroll, can you please talk to Lakshmi and finish the enrollment process before Wednesday? Because today is the last session, which is free, and from Wednesday we are going to start off the class with all the participants who are enrolled completely. Okay, you can drop your hands raised. Bring down your hands raised. Okay, I think we can start. Okay, I'm sharing my screen. I hope it's visible. Yes. Yeah. Okay. So, in one of the groups that I'm part of, I was asked if we can discuss few of the important terminologies in AI testing that we are going to use in the entire course so that they'll feel relatable and they don't get confused. So we'll be discussing about the important terminologies or the words, terms that we are going to use or the words that you must have knowledge about. Those words we are going to discuss about today. And along with that, yeah, in the previous class, maybe on Friday we connected last, right? So on Friday we have discussed what actually tokens are and what actually the embeddings are. How are they created or how are they thrown away into these embedding spaces and how each model provider has their own embedding spaces in embedding models, right? So maybe to go further, we will be understanding about how what is transformers, what is attention mechanism, self-attention mechanism, what is contextual embeddings, what are actually LLMs, and finally how LLMs works based on probabilities. Okay, this is going to be the coming topics. Okay, now most of you might have already known this. I encourage you to please give in answers if I'm discussing something that you have already known or you already know that or we have discussed it. Firstly, AI. Let us consider. Can you see what I'm drawing? I hope yes.
Yeah.
Yes,
Yes.
yes.
Yes. Let us consider this is the domain of AI. We already know what is AI. AI is a kind of machine that learns pattern from data and makes its own decision. Right? AI is a machine that learns patterns from data and makes decisions or predictions. And these AI systems, how do they work? AI systems use statistical models to approximate human-like decision making. Like they try to behave like humans. They try to make decisions like humans. That is what AI is. AI is not a deterministic language. It is pattern-driven prediction. Okay. Okay. I understood what is AI. Verma, you are giving me a same explanation, same definition for what is AI and what is ML. You told me that ML is also a machine or a model which learns based on previous data and predicts. Maybe it could be a numerical prediction, or it could be a categorical prediction, like predicting yes or no, or predicting some value. But how is it different from AI? How is ML different from AI? ML is a part of AI. Both AI and ML are the same machine, but work differently with a different technology. ML is the base version of what AI is, maybe drawing out rules from the data that is there, maybe drawing out the function which can approximate values based on the data. And what is AI? Before understanding the difference between what is AI and ML, we have to know another meaning, which is called as another term called as deep learning or DL. What is deep learning? Deep learning again is a kind of system which learns patterns from data. But how is it again different from ML? It is also ML, but an advanced version of ML with multiple models working together. Maybe a machine learning model is like this, and we give data, maybe input and output. What does it give in response? This builds its own function, which will give predictions of output. Okay, predictions. Now, what are we building using machine learning or deep learning or artificial intelligence? We are building a function for approximate decisions like human. Clear? I hope it is clear. Okay. And you might ask me, what is deep learning? What is neural network? Both of them are nothing but same. Okay. An advanced neural network is called as a deep learning network. And how do they look? Maybe for a kind of representation, how do they do it? There are multiple layers of these models. Maybe I can say in, in place of one model, I have a chain of models where each model is dedicated to learn a specific pattern. We don't specifically say that you learn about hair, I will learn about mustache, you will learn about skin, nothing like that. They decide themselves, maybe when an image is given for training, or maybe a text is given for training, all of this, they decide themselves what to predict or what to focus on. So when I said there are multiple layers, each layer consists of one model. Okay. These models are nothing but neurons. Okay. How are these neurons interconnected? Each neuron speaks to other neuron on a different network, like this. So now all of these neurons share information with each other. What is this information that they're sharing? The weights, or the importance, or the relation that they're giving between different parameters. Okay. Okay, fine. Now I have confused you again. What are these parameters? Parameters are these numbers which we get from the data that store the learned language. Maybe the weights are the, how many of you know maths? A simple maths. The coefficients that are given to each parameter, each field in the table data that we get. Okay, this is a simple meaning, right? More parameters are there, there will be more pattern complexity, more unexpected behavior, and more hallucination possible. Okay, fine. I understood what is AI, what is ML, at least a bit of it I got to understand. What is deep learning, I've understood. So now, how did it evolve? Firstly, it was a simple if else kind of logic. From if else, they've brought in stats and turned it into machine learning. And with a couple of machine learnings together, or machine learning models together, they built deep learning networks. On top of it, on top of these deep learning networks, we have built multiple things. We have built computer vision, we have built NLP, and we have built LLMs. This is where current AI is. So machine learning, deep learning, and AI are no different, but ML is a subset of deep learning. Deep learning is a subset of AI. AI is nothing but finding rules from the data to approximate decisions. Clear? And what are these parameters? Parameters are the weights that we give to each complexity that we learn so that it has its own importance. Okay, I hope this does not sound like some foreign language to you. It is all clear, I guess. Right? Now,
Maybe you can give an example
Yeah.
of.
Hi,
Uh,
Varma. One question here. So you're
yes.
saying that these are neurons, right? Neuron
Yes.
means, is it a value? Is it a dimension?
Okay, I'll tell you.
Is it a token?
Neu-
What is it like?
Neuron is a kind of model. Okay. In machine learning, we stack up these models together. Models, weak models, all of these are models. One model will learn something, another model will learn another thing. Now, let's say, let's say we are preparing for an exam. Okay. Let's say we are preparing for an exam and we just have 2 days left. And in engineering, I hope when I learned engineering, it was 5 chapters in a subject. Okay, one subject. And we are 5 friends. Okay. Now, in 2 days, no matter what I do, I cannot completely learn all 5 chapters. Right? What I'll do, we all 5 friends will discuss that. Arey Baba, you learn one chapter, I learn one chapter. You another guy will learn one chapter, and 5 people will learn 5 chapters. And one day before, we all will meet together and share our knowledge, which will give us at least better results. Right? So now, what is happening here? One is a weak learner, two is a weak learner. All of us are weak learners. But all these weak learners together are forming a neural network. Okay? Neural network. And each of the component of this neural network can be called as a neuron. Okay? And each of this neuron works on a principle of an ML model, a simple model, which is a perceptron. We don't have to learn much about perceptron or how it approximates because it is too much maths into it. So you can consider each of these cells of this network or this layer can considered as one weak learner. This one weak learner can be called as a neuron. Clear? I hope this example gives a lot more clarity than what we've discussed.
Yeah, yes, Varma. Thank you.
Yes, right. Now, I hope the questions are clear. Can I go ahead? I hope it's a yes. Okay.
Hey, one question.
Yes, Chitra.
So can you go to scroll to the top where you have a
Mm-hmm. This one.
no, the where you have the AA, ML and so which one is the subset of which one? I thought AA is the bigger bucket, ML is the
Yes.
subset of AA, and deep learning
Yes.
is a subset of uh, ML. Maybe
No.
whatever you wrote in the top and the picture is they
Mm.
are like not going. I just want to make sure that I clarify that.
ML has a superset, which is deep learning. Okay. ML has evolved into deep learning. Okay. And deep learning has evolved into AI. Now you tell me ML is a subset of AI. At the same time, ML is a subset of deep learning. Deep learning is subset of AI. So all of these are one single circle. Okay. All of them have evolved from each other, from if-else statements to machine learning, including statistics. And all of these weak learners together started to build deep learning. And group of deep learnings are a kind of complex architecture of this deep learning will turn into transformers or not to confuse you, nothing like nothing but AI. Okay. These AIs or LLMs, NLP, CV, all of these are kind of called as transformers. We'll discuss about what is transformer again. Okay.
So one second. So this deep
Mhm.
learning, this machine learning is the subset of DL or AI?
I didn't get your question.
Based on your circles, right?
Mhm.
AI, this DL is a subset of AI, right?
Yes.
And ML is a subset of DL.
Yes.
Both.
Both.
ML is subset
I
of
can say
DL as well as AI.
AI. Oh, see,
Okay.
AI consists of ML. So not to confuse you, it is like AI is nothing but machine learning in an advanced form. Okay. AI, deep learning is nothing but machine learning in an advanced form. Just like I actually have drawn a kind of a roadmap here, right? There were if else statements before. People could not cover all the scenarios. So they have brought in stats, and this including the stats, they have built machine learning models. That's how we landed up or ended up having machine learning. And on top of this machine learning, people started to experiment with ensemble of models, multiple models, and then crack the logic of deep learning, which is building a neural network. And then from deep learning, people have found complex neural networks or built complex architectures which lead to what we are having today, LLMs, or the main word AI or generative AI. I hope this flow at least clears your doubt, right? Okay. Now, what is training now? Sorry, I can't take any more questions now. We'll take all the questions in the end because it is taking a lot of time for now. Okay. Now, I understood what is AI, what is ML, what is deep learning, and what are these parameters. Okay, now, what else do I want to learn? What is training? People talk a lot about training, right? I'm training an LLM, I'm training a machine learning model. I have to predict all these fancy terms they use. Now, what is training? Training is a kind of learning phase where we feed in all the data to the models. It could be a machine learning model or it could be a deep learning model. End of the day, both of them are models and all of them need training. So based on that data, it'll bring in that mathematical equation so that it can give probabilities or give outputs, right? Give the predictions. And once this training is done, what do we have to do? Once the training is done, I have to predict or inference. Inference is the word for calling the trained model to generate an output. Okay. Calling that trained model to generate an output is called as inference, right? And this is all for complex AI stuff that we don't have to learn in depth. We have something called as token. What is token? There is a big sentence. I want to chunk these words or chunk this sentence into smaller words. Small piece of text that a model can understand is called as a token. Okay. These tokens are going to be the input, and these tokens only are going to be the output. Tokens are nothing but words. In generative AI, we give words as an input to LLM and we get words as output. And those words paired together, sentences, right? So tokens are nothing but chunks of bigger sentences. Okay. What is tokenization? Tokenization is a concept of converting these bigger sentences into smaller chunks. And yesterday we have discussed what is an embedding. For these tokens, we do some kind of pre-processing and throw them into a vector space. Like I told you yesterday, I'll do a kind of visualization. Let's say this is the space. Let's call it some, I have drawn three-dimensional because that is the only number of dimensions that we can bring in a drawing. In three dimensions, this is the space. Okay, there is a word called as king. King is converted into a vector. Let's consider this as a vector king. Now, queen is also a word. This also falls close to the same vector because they both have a similar meaning of royal, right? Now, there is a word called dog. When I throw dog into this embedding space, can you say that dog, based on the understanding that you have got on Friday, can you say dog will go sit here? No, right? Dog has a different
No.
contextual meaning. Dog will go sit somewhere in the space where cat again is similar to it because it's an animal. It may be somewhat close, like here. It can be there. Or let's say there is a man. Man and king share a common meaning of having male as gender. Now, maybe I cannot say it falls directly close to king, but in this multi-dimensional space, both of them might be standing parallel to each other, but not close to each other because they share a same meaning. If it is parallel, I should have not drawn it here, maybe here. It is parallel to king because it share a similar meaning or similar gender. Like that, when we throw in all these tokens, they are converted into vectors and placed in a vector space. And the placement of each word or each token in this vector space is decided by the meaning it holds. And how close or how far these words are each like to each other is based on again the similarity and difference at the same time. Clear? And now we also discussed about something called as contextual embeddings. What are these contextual embeddings? Yesterday I told you there is a word called as bank. Let's say here it is bank. And this bank could be a river bank or a savings bank, right? Now, when let's say I was at riverbank and there is a word called savings, there is a sentence called savings bank is safer. Now, when I turn or tokenize these sentences, how would I tokenize them? Like, I was at river
Riverbank.
and there is one more thing, bank. Now, I have one, two, three, four, five tokens. Now here, again, savings is one token, bank is one token, ease is one token, safer is one token. I throw all of these words into the embeddings. Okay, into the embedding space or vector space. Now, the bank here and the bank here, both of them are compared as individual token. Do you find any difference between both of them? Bank is a bank. The word itself is a bank. But when it is placed with some other words or some other tokens in the sentence, then there comes a value to it. That means there holds a value with who its neighbors are. Okay, the word meaning changes based on the surrounding words. That is what a contextual embedding is. I hope it's clear. Okay, and we are talking about something called as, this might sound a little complicated, but it is not. You can ask any questions, you can shoot any questions when I'm discussing this, but we are talking about something called as transformer, not the voltage or current transformer. This transformer is going to transform the AI space. How? These transformers are the architecture
Excuse me, sir. Hello.
Yes,
Is there any grammatical check during contextual embeddings?
yes, it understands grammar.
There's some lexicon relationship between words or sentences.
Yes, yes. So it like not just we are directly throwing them into the vector space, Mister. It is actually like we are training those models, or we are already feeding that particular embedding space with all the text corpus a company can think of. Okay, we are already putting in all the tokens into the model. So whenever a new model or new text is coming into that model, it treats them directly or takes those vectors directly into the space where it belongs. Okay, so now imagine a model which is trained completely with the entire English corpus. It will obviously understand the grammatical errors. It will obviously understand the punctuation marks or the intent behind the sentence that you have written. Okay,
Okay.
right.
So it's
Now let's
the
talk.
so so it's the developer responsibility to train the model or testers.
Yes, it is developer's responsibility to train the model completely. And the best part here is you can't directly go talk to developers also because there are two types of models that are there. Okay. First is in-house model or in-house LLM, which is specially trained with your own company's data. And there is another, which is the provider LLM. Okay. Which is a kind of model provided by somebody else. Okay. There are different providers. There is OpenAI, there is Claude, there is Gemini. There are multiple people who have trained it so that, like, if you want to like expose an endpoint, let's say, do you directly write entire thing or you will build all the network systems, you will all build the VPCs, all these things. Do you do that manually? No, there is a cloud service provider. You just have to drag and drop what you want and build things based on which is already built, right?
Okay.
Right?
Right, sir.
In the same way, these giant companies or MNCs have built these LLMs and hosted them somewhere, and they are accessible to all these developers in a paid model. Like for each token of input that is given in and each token of output that is coming out, they charge amount. Okay, they charge money because just like other cloud services, these LLMs are also being provided by these huge LLMs, like LLM providers. Got it? So now, whatever text corpus that is already being trained for these LLMs is either being done by OpenAI, Claude, or Gemini, or there could be also a chance where people are training them in-house. Actually, training these LLMs in-house would cost them a lot more, but still, if they want a specific use case to be solved and they're concerned about security, they're concerned about different compliances with their clients, they train their own in-house LLMs. Or maybe if they want to compete with one of these giant companies, they can train these in-house LLMs. Okay, now, end of the day, nobody's training these LLMs in our companies. Mostly, they are getting these provider LLM APIs and making API calls to them. Got it?
Yes, sir.
Okay.
Got it. Thanks.
Yes. Okay. Now, everything is fine, Verma. We discussed about token, all these things is fine. But what are these transformers? Transformer is nothing but, let's say, you're driving a bike and there is an engine behind it, right? Which is making it run. That is what a transformer is. Transformer is not a physical thing, it's a model, a complex model which has the architecture. Like the architecture behind these modern LLMs is what transformer is. Okay. And these transformers will build all this attention mechanism or contextual embeddings or whatever understanding that the LLM needs are brought in by these transformers. Okay. Transformers are nothing but complex programs. They are not hardwares. They are not any
So,
systems.
so
They
we
are
can
complex
say
problems.
we can
Yes,
say this transformer is kind of orchestrator in all of these AI, whatever a big LLM is, big LLM model is. So transformer is kind of orchestrator who make sure everything is in sync.
transformer is the brain behind LLM. Okay. They're like not to you like we cannot use the word orchestrator here, but it is the one thinking behind these LLMs. Okay, there is some other context where we use the exact word orchestrator that going forward we will learn. But this architecture behind these LLMs is what transformer is. Okay. We don't go deep into what transformer is, how it works, but we will understand how things around it work. Okay, these transformers have special features. What is it? These special features are attention mechanism. Okay, what is this attention mechanism? Attention mechanism is a kind of process of predicting words or predicting responses. Predicting responses. The model or the transformer behind these LLMs is not going to predict one word after other. It is going to predict parallelly with a couple of words or with a complete sentence at a time, where with each word, it will compare all other words in the sentence, just like the contextual embedding thing that we discussed. While generating a sentence, it looks at or it gives attention to all the words that are part of this sentence. This is what an attention mechanism means. Model decides which words are important to use, which words are to be put in this particular sentence to make it meaningful. Okay, right. That's all the complexity. Now we'll jump into the simple terms or terms which you can relate to. Right. Now there is something called as a context window. I'll go back to the same example that we have taken. The five, where did it go? Okay, I'll just zoom out a bit. Okay, here. Now I said that we are five friends and we decided to learn five chapters. Each chapter will be learned by each person, and we are going to come and throw it out, make all others learn. And now I'm not talking about these neurons or students that we are, but there is a limit, right? Even as a human, how much can you take in as an input? In one night, there is a limit. For this particular guy, he can only learn one chapter per day. This particular guy can learn two chapters. So there is a limit of how much it can take in as a request or input and how much it can give out. There is always a context limit, how much it can talk about or how much it can take in. Sometimes, not now, but sometimes before, when we used to chat with Chat GPT, now they have fixed it with the sliding window approach. But previously, maybe some people might have used it in the initial releases, maybe GPT-3 releases, when you would have asked a long question or something which needs a longer explanation would have failed, like context limit exhausted, or something like no, I cannot answer your question because it is out of my context limit, something like that. Because it can take only a maximum amount of memory that it can hold at one time. So this is called as context window, the maximum token limit or token length a model can process simultaneously. Got it? There is a limit that it can take input and there is a limit that it can give output. And you can ask me, do all models have the same context limits or context windows? No. Each person is having a different context limit, right? In the same way, each LLM will have its own context limit, right? Each LLM will have its own context limit. Like there is a model type. There is something called as GPT-4o. GPT-4o, and there is something called as GPT 5.1, let's say. This particular model type will have some complex context limit, and this will have some context limit. Both are different. Each model type will have its own context limit. Okay, that is what a context window is. Maximum amount or maximum token length or number of tokens that it can handle at a time is called as context window, right? Got it?
Yeah, so it is basically the number of words or
It can
number
hold.
the yeah, number of words or the data you can provide an LLM in one go to explain your
Yes,
problem.
yes, that is what context window is. Now, the information that we are giving in or the input that we are giving in is called as prompt or instruction. Instruction is nothing but a prompt that we are going to use. Okay. And what is a completion? Completion is the response that is given. You must have heard these things before, maybe when you were asked to test these AI responses or when you were working on these AI projects for testing, there is something called as completion or the output, model generated output is called as completion. Okay. And there is one more important thing that you need to understand, that is temperature. Temperature is the amount of creativity that it can bring in to answer your question. Maybe this, if this temperature is huge, we are permitting it to use huge amount of creativity. Now it will try to be more creative and hallucinate. It will give wrong answers. And if I give very less creativity, it cannot form a complete sentence and it will fail. So we have to find a sweet spot somewhere here where it is, yes, it is creative and also it is not creating false information. That kind of temperature needs to be found. Okay, this is all.
Do we
In,
do we really decide temperature on our end in our actual real world, or it's the OpenAI or Claude which decides the
no,
temperature?
we can decide it. It's a parameter that we give into the model. We can decide how creative that can be or how not creative that can be. We can give it. And at times, as a tester, we might have to decide the temperature also. Like we can try, like let's say there is a test case that you have written. You can try it with temperature 0.1, temperature 0.5, temperature 0.9, like that. Multiple temperatures you will be giving in as input and validate the response as well. This could be a task of yours as well. Okay.
So do we
Temperature
do
is the,
we have any metrics for this to set the temperature and all?
it depends on model. It is more towards like a trial and error approach itself. Okay, it is more like trial and error approach itself. Maybe based on the prompt that is given, it can vary, or maybe based on the model that is picked, it can vary. So we have to find different, like it is not like this is the temperature where it gives perfect answer. You have to find the sweet spot where it is giving perfect answer based on your requirement. Okay. Now, these are different technical terms. And now we are going to understand about failure or risk terms, which are very much important for AI testing. I hope all of you are making notes. If not, you can watch the video recording and make notes of it. Okay. Now, what is AI testing? Like in AI testing, what are different terms? One, we use it a lot, something called as hallucination. What is hallucination? If a model is giving confidently wrong answers, that is called as hallucination. That means it is not being able to give correct answer. Then we can call it as hallucination. Next, there is something called as bias. What is bias? Model reflects social stereotypes. Like when I go and say something like maybe a gender biased question. If it responds back in the same kind of tone without correcting you, then it is having a bias in its training data. Statistical pattern that it learned from was biased. Okay. And for testers, bias evaluation is required for fairness complaints. Okay. I will just write the kind of metric that we are going to validate here using hallucination. Like by looking at hallucination, we are going to validate truth verification. By evaluating bias, we are going to talk about fairness complaints. Okay. And there is something called as non-determinism. Same input, there is always a different output, which is called as non-determinism. We cannot say how or what word it is going to use for predicting answer for the same question second time. Okay. Then we have a word. I'll zoom it a bit. We have a word called as overfitting. That means it whatever data it was trained on, it is giving good answers for what it is trained on. But if there is a completely new data for which it has to predict, it will fail. That means it is memorizing instead of generalizing. Instead of understanding, it is just storing them in memory. It is just memorizing instead of understanding. That is called as overfitting. And
Can you please explain the overfitting little more?
about overfitting,
Yeah, with an example probably, just
okay,
to make sure I understand it.
okay. Let's say, uh, uh, I have a model. Let's take an example of machine learning model, or let's take an example of some kind of LLM. Okay, machine learning model I will take. Let's say I have trained all the data about a class students of a class. And now when I given their name and roll number, the model should name, roll number and age, the model should predict height of that particular person. Okay. Now I have trained entire data of complete class. Now, whenever I ask anything about our class students, it is giving right answer because it is trained. And now, if somebody else from other class, it should be a generalized one, right? Because we are not specifically training for one class. We are training for a generalized purpose of estimating height based on their age, based on their age and maybe some other parameter, age and gender. Okay. Now I train the entire data of one class and I pick and give data of class for like some other guy. It starts to not give answer or wrong answer. It starts to give. Then it is called as overfitting. That means the data which I am trained it on, for it the model is responding perfectly. But for the completely new data, it is not responding perfectly. That is what overfitting is. Okay. We will talk maybe you will just have a glimpse of it now, but over the time you will learn what is overfitting. Okay. Next, what is RAG? RAG is the most heard word of generative AI. What is RAG? RAG is nothing but this model is trained. Along with that, I will give more documents to it and ask it to generate. Retrieval augmented generation. RAG means retrieval augmented generation. So now, instead of completely relying on models trained data, what I will do is I will show it multiple documents that I have. And every time I ask a question to the model, what will this model do? Instead of completely relying on its knowledge, it will go search these documents, get the answer, make it properly framed, and give it back to the user. This is what RAG is. Okay, we will discuss in depth. And what is fine tuning? Fine tuning is nothing but training. Okay, just a fancy word of training is fine tuning. Yeah, these are different terms that we have discussed. Oh, yeah, these are different terms that we are going to use as part of our course. And having knowledge of all these words or just a idea of what all these words are would be a great add-on before we start the class. So yes, this is all we wanted to discuss. I see Deepak raised your hand. Yes, it's time for questions, buddy.
Yeah. So, can Dakshin, can you share your screen, the same slide which you were, not
Yeah,
the slide, but the same notes which you were making? So,
this one.
in the AI testing, yeah. So, yeah. So out there we do have one concept of drifting also.
Mm-hmm.
So that is also considered under like the AI testing terminologies, drifting.
Yes, but there are different
Mhm.
meanings to it. Like some people call it defting, some people call it a different word. Maybe I should
Okay.
look into that and come back.
Okay, no problem, no problem. Sure. So
Yes.
so can you go up like on the 16 parameters like yeah. So like you were discussing about a term known as vector space vector, wherein
Yes.
it was
Yes.
it was it was post tokenization, right? Or it was in the
Post
entrance
tokenization.
post
Post
tokenization.
tokenized. Yes.
Okay. So the vector space when you're talking about and discussing is vector space is nothing but it's kind of a database are we talking about kind of or like because we were finding similarities between king and queen and cat and dog and
Yes.
then man and so it's kind of a
Yes.
open database you're talking about, right?
Yes. Yes. It
Okay.
could be a database or it could be these embedding models context. And all these embedding models will have access to their own vector databases, using which they'll convert
Okay.
all these tokens into embeddings.
Okay, perfect. And then we were you were talking about the prediction responses wherein you gave some the transformer kind of you give the weightage. So
Mhm.
weightage will be decided in the transformer 11th or 12th point. It will be in the post the like embedding, like how that responses will be given to the user, like from the LLM models, like how will be that weightage
Yes.
will be in the embeddings or it will be post that.
Weightage, addition of weightage or allocating these weightages to all these model text is part of the training process itself.
Okay,
Okay,
training
this is
first.
all is after embedding these models or after understanding these words. And the process of understanding these words itself is
Mhm,
embeddings. Okay, and
mhm,
these
mhm,
transformers, maybe I told you, know, the attention mechanism, self-attention mechanism is how
mhm.
it generates responses.
Okay,
Okay,
okay.
there are two
Mhm,
phases of it. The transformer getting trained, and when a question
mhm,
is asked,
mhm,
while the response is given, it will use
mhm,
all the embeddings that is there with it, with the knowledge that it has, and
mhm.
rates each of the word, gives weightage to each of the word. What word should be picked? Okay.
Okay, okay, okay. And the same
When I
concept
say,
is.
yeah,
Mhm,
1 second, I'll just
yeah.
clarify this question. I've
Mhm,
taken the
mhm,
example of Riverbank and savings bank. Now, if a
mhm,
person
mhm,
comes and asks, like, where should I save all my money? Okay,
mhm,
there are all
mhm,
these words with it. It has Riverbank, it has savings bank. Now,
mhm,
with bank, what word should be used for this question? There are two of these. This should give weightage to one word, right? If I say you should save all your money in Riverbank, does it make
mhm,
sense? No, right? So
mhm,
here
mhm,
there is a kind of ranking that is being done internally between these words. Which
mhm.
one should be placed here in this sentence? That is what the attention mechanism is. Predicting these responses by giving importance to all the words that are there in the sentence.
Okay. And then and in point 16 when you said about temperature. So either way in temperature also we are giving weightage, right? So we'll be
No,
giving.
no,
Okay.
no, no. In
Okay.
temperature, we are just telling it how creative it can be. Like, let's say if you
Okay.
don't know an answer,
Mhm.
if I
Mhm.
put entire creativity, like there is one as maximum limit that you can give for temperature. If you put
Mhm.
one temperature, it will
Mhm.
try to create answer that you don't know. Okay, just like we write answers in the exams, which we don't know, right? We just
Mhm.
write
Yeah.
stories and come back. Just like that, it'll start writing
Mhm.
its own story for it,
Okay. 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 Okay.
right?
Mhm. Mhm.
And
Yeah. Mhm.
any more questions, guys?
About that non-determinism. Uh,
Mm-hmm.
so, like every model we see answers are like if for the same question, like initially showed, every model has a different answer. In fact, for the
Mm-hmm.
same model itself, if you see, it's a different answer. So,
Different
is
answer.
that a feature we can make it more determined, as in it should be in the simpler lines?
No, we cannot determine the words it uses, but based on the prompt that we given or the instruction that we put in, we can instruct the model how that particular response can be. Like you can set the format of how it answers, but you cannot determine the words. You cannot give, you should use only these words as a response. It will pick whatever it comes to its probabilistic nature. But you can always dictate the structure. You can always dictate the way it thinks or processes the each question.
Okay, okay. And you said fine tuning is a training model, as in it's a data which we are teaching. That's what you're talking about, the training thing, or
Yes.
fine tuning is a
Yeah.
different one?
Yes. Yeah. Both of them are same, but in different contexts, we use different words. We can't say we are fine tuning a model, like we are fine tuning an LLM. Okay, based on the context that we come across, we use different words. We will discussing about them while we go through the course.
Okay, okay, fine, fine. Thank you.
Yes. And guys,
So
Yeah,
Taksham, the session. So the classes will be for exactly 1 hour, or it will continue till 10:30
if
Indian
you,
Standard Time.
yeah, if you have more questions, I'm always ready to
No,
sit
no, no.
with
I
you
mean
till
to say
12:30,
not for
11.
today, not for
Yeah.
today, but I'm talking
Yeah,
about tomorrow,
every
like
day, every day.
the
Yeah,
regular classes
tomorrow, yeah, regular classes. The
will
content
be
that
till.
the content that I'll bring in for the session will be for 1 hour or 1 hour 15 minutes. Okay, this is a
Okay.
kind of
Mm-hmm.
40-hour course that we have designed, and
Mm-hmm.
each hour we have designated each topic to be discussed. So I'll bring in topic that is worth of 1 hour. Okay, after that,
Mm-hmm.
whatever questions that you have, we will
Mm-hmm.
that will be extending the time from more than 1 hour.
Okay. Okay. Mhm.
And yes, Sudharani, you were
yeah,
you have
yes,
unmuted
Varma.
yourself.
Yeah, I
Yes.
want to know about this RAG. The RAG is one lay. Is it a layer on top of some model? Like whenever
Yes.
we feed some documents, if I input something, so the output is depending on these documents only, or it will fetch from outside also and give us the
No,
output.
you can control it. You can control it to only use these documents, and you can also control if it can use its own external information or its own trained knowledge.
It's trained knowledge. It depends only on the documents what I
Documents
feed in.
knowledge. Yes.
Documents
Yes.
knowledge only, right?
Yes. You can
Okay.
control it. Like which which references it has to take in. All of that you can control it. Okay. We have specially put a kind of 4 to 5 day on understanding racks and testing racks. Okay, so you'll be extensively understanding how RAG architecture works, how it is a wrapper around LLM, and how you can control it. You're going to understand advanced concepts related to RAG over the time.
Okay. Yeah, thank you.
Yes. Any more questions related to course or related to the topics? Because this is going to be the last free class that we're going to take. Maybe after that, you'll have to enroll. So whatever questions that you have regarding course, you can ask. Shoot.
Yeah, so Dakshin, last one from my end, which was
Mhm.
related to the MCP server. So as of now, RAG is a system wherein, like, what I know, and according to my understanding, it gives you output as per the database or as per the model being trained, RAG system. But it
Mm,
doesn't
mm.
act on behalf of you. So that's the difference between
Mm.
RAG and between the agentic AI. That means I meant to say MCP
Yeah, I'll tell
servers.
you.
Yeah.
So RAG, as I told you, it has access to these documents, and these documents are referred to while answering the question. In the same way, this agent will have access to different tools. Okay, these
Mhm.
tools are like, let's say, huh, I think most of you will be maintaining these Git repositories for all the code that you write, right? Let's say
Mhm.
we are handling a use case where you have to write documentation or usage document for or readme document for the repository that I given. Okay. Now I will given this task to agent. This agent will have all the tools. Okay. These tools
Mhm.
include open file to search file, three. It could be related to search file, open file, list file items. Okay. And just like we do Control F, you're going to search, right? In the same way,
Mhm.
the search tool is there. Okay. In similar ways, there are different tools that are there. Now,
Mhm.
this repo is fed in, and this agent uses all these functions to run or to look at this repo file content and generate a kind of documentation. Now, agents are more task oriented, and RAG is more question oriented or answer oriented. Okay.
Okay. Mhm. Mhm.
And you can merge both of them together and call it an agentic RAG.
Okay.
Got it?
Mhm.
There is a good amount of thing that we are going to discuss about these things. And
Mhm. Mhm.
as I said, you were talking about MCP. What actually
Mhm.
MCP is, right?
Mhm. Yes.
I write an agent, you write an agent. Okay.
Mhm.
I write
Mhm.
different tools and you write different tools. Now, let's say I want to integrate my agentic framework with your agentic framework. Okay. I write in a
Mhm.
different syntax, you write in a different syntax. Now,
Mhm.
imagine we both are working together, or these two agents should communicate with each other with the tools that they have. If there
Mhm.
is no standard way of writing things, this agent speaking to this agent will confuse a lot, right?
Mhm. Mhm.
MCP, Model Context Protocol, is
Mhm.
to give these agents the context that it requires regarding tools or documents or different resources. There is a standardized
Mhm.
way of writing things. That is what called as MCP. Okay. Now, by building
Mhm.
this MCP and pairing it with a fast API, now each of these agents can talk to each other about their tools, about the resources that they have, about the knowledge that they have using these fast API endpoints, understanding their model
Mhm.
context protocol. I hope I've
Okay.
explained it
Okay.
much better,
Mhm. Yes.
but
Yes. Yes. Yes.
we will discuss that in depth. Yeah.
Mhm.
Yes,
Yeah,
Poonam. I hope I've answered your question, Deepak.
Yeah. Yeah.
I'm
It's clear. Yeah. It's clear.
Yes, yes, Deepak. Yes, Poonam.
uh,
I
um
see you raised your hand.
basic question actually. What is agentic AI as in
See,
an
a
LLM?
simple explanation that I can give is an LLM can only take input and can only give you output. Maybe it can most possibly talk to you, but an agent is a kind of thing which can take in your commands and process or do things that are in its scope. Let's say I I'll share again, like it is being shared right now. An LLM is there or a chat GPT is there. You go and ask bro, I want to compose this email. What can it do? It will just compose the email and give you a email draft, right?
Right.
What if this LLM is connected to different tools or integrations like Outlook is integrated? Huh? Calendar is
Mm-hmm.
integrated. Now, when I come here and say, bro, I want to apply a leave for another 2 days, I'm feeling sick. Can you send out an email on my behalf? What it'll do? It'll draft this email. Okay. It'll cross verify if everything is correct. It'll ask you, bro, should I send out the email? The moment you say yes, or you if you give it full control without even asking you, it'll send out an email to Outlook and schedule out of office in your calendar. Imagine
Okay,
how it is
so
being done.
so
That is
basically
what
it'll use
AI.
LLM and then work for you.
Yes, it'll use LLM with the kind of tools that it has. That's what LLM will answer you. But an agent, with all the scope of work that it can do, it will take decisions and operate for you. That is what an agent is.
Okay. Okay, fine. Thanks.
I hope this is clear. Yep. Chitra, I saw you raising your hand. Yes,
Yeah.
Chitra.
So what is the scope of this course? Like, will you be like in addition to RAG, I understand, but
Hmm.
agentic AI and MCP, all these systems uh,
Hmm.
you will be covering, or it's just
Yes, I will be covering how to test these things.
you mean
Okay.
RAG, agentic, and MCP?
Yes,
Okay.
we'll be covering testing of all of these tools or all of these frameworks, AI frameworks.
So are they all the same?
Aren't they all the same anything? Like
The
each of
testing
them hold, yeah, testing, yeah, most of them are same, but it has to be like the mindset of what we are writing or with the mindset that we have around NCPs and around LLMs will change. Around these agentic AI and agentic RAG will change. So how to think, how to write, and how to execute them based on the application that you are testing, it is different. So it changes from the kind of application it is.
Okay. The reason I asked is because, this is all vast amount of information, and within this 40 hours, how will we learn this fast? That's the only question I have on my mind. You will be going so fast, or how is your class structured?
The class is structured to follow the process. Like we are going like this
1 week,
is
my question is it 1 day, 1 hour RAG testing, and next day agentic, and then the
no,
MCP?
no,
Is it
no,
all
no,
one week,
no.
1 week?
1 week we'll be testing one kind of application.
Okay,
Okay.
okay,
We will
okay,
be understanding each thing or each term very deeper way. We will get complete understanding and then proceed to the next one. Okay.
the, okay. The only thing I feel like you will be coming up with those example systems
Yes.
to do the, to be able to test
Yes.
the already built-in applications.
Yes.
Okay.
Already built-in applications or already built-in workflows that you can run locally. Okay.
Oh, okay, okay. So we can run them in our
Yes.
environment.
Yes. You can
So
run
do
them
you
in your
have a
environment.
requirement for the machine, or like, what kind of that you will be letting us know when it comes?
Yeah. I'll be letting you know when it is required. And also, mostly, we will be working with API calls so that you don't have to have highest compute at your thing, your system. You just have to make API calls to these AI providers. As I already told, you don't have to run all these AI LLMs on your system. You just have to talk to the provider, like communicate with the provider's API. That's all.
Okay. I'm excited.
Yep. And that's all for now, I guess. Maybe we can wrap up. And I see most of you who are here today, yesterday, and day before yesterday, also in the Wednesday's class. Thank you all. Thank you so much. You can drop off.
Thank you. Tomorrow we don't
Thank
have
you.
class, Dakshin. Tuesday.
Yeah, tomorrow we don't have it. So
Okay.
like
Okay.
if we start immediately, some
I
people
know.
might lose their lose the info
Mhm.
that we discuss. So we are giving 1 day time, an extra time for enrollments to be
Mhm.
finished.
Mhm.
No,
Mhm.
sorry, you don't have a class or you, I'm confused. I thought you have the
We
class
don't
tomorrow.
have a class tomorrow. We don't have a class tomorrow.
When is
That's
it
only for
starting?
tomorrow, right,
Yes,
Varma?
only for tomorrow. Only
Yeah.
for tomorrow we don't have a class. From Wednesday, we will be continuing with our regular lectures.
Okay, got it. Thank you.
And I know I keep asking this question, but you will be providing notes, right? This is very theoretical, at least, to go
Yes.
through and revise. So you'll
Yes.
be
I'll
providing
be
notes.
providing
How's the
I'll
course?
be providing different links. Yes, I'll be providing different
Okay, okay.
blogs that you can go through to understand things better. If you want, see, like if you have a tester's mindset, you always think of breaking it. But if you have a developer's mindset, the more you explore, the more information you'll get.
True,
Okay,
true.
it is never the end of information. So it is always based on the extent of information that you want to learn. With at what extent you'll feel satisfied. Based on that, I'll be providing links or links to these blogs. Okay.
Thanks.
Yep. Thanks all. I'm dropping off. Bye.
Thank you, Dakshin, for the
Thank you.
wonderful session. Wonderful.
Thanks.
See you on Wednesday.
Yeah. Bye.
Bye bye.
Thank you.
Thank you.
Yes.